Hi everyone. I just realized earlier, let me skip back a whole bunch. I went over pseudocode exercises and you can definitely, sorry, not past the pseudocode here. All right. I left you guys with this exercise here. How do I figure out how to add 5 different assignment grades and see if someone passed? I have a discussion about this in another video, the video involving um, code, how to debug code and how to reason about your code. Code debugging tactics, if you will. Although we're getting ahead of ourselves with code debugging tactics, I put that up there, but this is also attached to that earlier video. All right, so let's go to, after we do all this code debugging tactics, let's go to flowcharts. This is just yet another way of us being able to reason about code. It's just a more visual way. You're not writing as much English, you're just sort of drawing pretty pictures. Great. The idea is I have this flowchart, much like your code actually does, what your code actually does, where I have some starting position. Actually, it's always with the oval here. It will go line by line along these lines. The quadrilateral symbols input data, so you asking the user to type in their name, for example, or type in their age, would go into something like this. A rectangular symbol is when you do a particular action, like I'm going to remove all the number 4s from this set of data, or whatever the case, or I'm going to sort my data. And a diamond is a conditional, as in, if this is true, then do this, otherwise do that. And it looks something like, hopefully it's there, there we go, something like this. So here's a flowchart sequence. I have some starting condition, that actually should be a circle. Well, that's circle and circle. It looks slightly different, should be more, but it should be more rounded. I'm going to buy a chocolate bar. I'm going to unwrap the chocolate bar. I'm going to eat the chocolate bar. Great. I'm going to end with diabetes. No, I'm going to end up being sick or more overweight than I already am. Okay, so that would be a simple flowchart. What if I have a conditional in there? So instead of this direct line, I'm going to go to a conditional. I'm going to see if my friend is next to me. Is your friend next to me? If so, offer them a piece of chocolate. If they are not, eat the chocolate bar. Okay. Notice you offer them a piece of chocolate. It doesn't matter what their response is. You still eat the chocolate bar because you're a jerk, it seems. But this would be a conditional in effect. Okay. Well, uh, you should have something else in there. Is your friend next to you? Yes. Are they hungry? Or you can offer yes, offer them a piece of chocolate bar. Are they hungry? Yes, offer them a piece of chocolate bar. Notice this is a loop. I keep on asking them if they are hungry, and as long as they keep saying yes, you offer them chocolate bar. Notice it's not actually correct. Are they hungry? I probably should say, and there is still chocolate remaining. If so, if they're hungry and there's still chocolate remaining, you keep on offering them a piece of chocolate bar. I would probably want to expand even further than that. If there's still some remaining, and if there's still some remaining, and they're hungry, and you want to offer them the chocolate bar, then keep on offering them a piece of chocolate. Right? There's a bunch of different ways of approaching this. This just happens to be one example. Here would be another one. How do you butter a piece of bread? Right? I start by removing the lid of the butter. I need to probably take it out of the fridge, maybe if you're using butter from the fridge. I place 5 grams of butter on a knife tip. Okay, position the tip forwards. Move the knife. Is the bread coated evenly coated with butter? Otherwise, add more butter. Notice this is an infinite loop. Technically, if the bread is never coated evenly with butter, it also doesn't say anything about if you keep on putting the butter on the same point on the bread that you're not trying to, you know, we should say something about smearing it across the bread in approximately even thickness and attempting to cover all the bread, something like that. But this is just an example of a flowchart. We have a conditional. It Our if statement allows us to loop without having anything special. We just have some kind of loop. We're just flowing around in a circle, uh, and these conditionals allow us a lot of power. So, how do I add two numbers together? So I have my starting condition. I'm going to read data. Notice this is our parallelogram symbol here. I'm going to read data 1, read data 2. You're going to store values in data 1 and data 2. I'm going to add data 1 and data 2 to some variable called sum. I'm going to print the sum, so that's output, input, input, output, and then I'm done. If I want to add a whole bunch of numbers, here's what we had earlier with our example with our pseudocode. I'm making a variable called counter. I'm making a variable called sum. I check to see if the counter is less than n. If so, I read in data. I add that data to the sum. I increment the counter, loop around again. Is the counter less than n? Yes. Okay, read in another number. Sum it up, increment the counter. I keep looping around until the counter is equal to n. Then that's no longer the case. It becomes a no. I then print out the sum, and I'm at the end. It is meant to be allowing you to visually scan or understand what your code is actually doing. It's extremely powerful, although it can get a little clunky. Okay, so here would be an alternate way of checking to see if a student passes or fails the exam. This is taking information from about the student's grades each and every time, I do believe. So we read a student grade, we see if the student grade is less than 60. If it's less than 60, we print passed. Are there more students to check? Yes, there are. This is which students passed the exam. Essentially, every time a student passed the exam, we print passed. Otherwise, we print failed. Why? I don't know why. But you have, in this case, 400 students in the class. You'll do this 400 times. Each student, you check to see if they pass or they fail. If there are more students, then so it will go from 0 to 5, as you said, 400 students, so 0 to 399 students. We'll do that 400 times, looping around, getting a student grade, checking to see if it's less than 60. If it's less than 60, I print failed, otherwise I print passed. Notice both of these branches go straight here to this, where they connect up here, and I check if I have more students. So I would like you to make a flowchart. Take a break with the video in a second when I've finished explaining things. So we're going to have a troll, and the troll is going to walk towards a wall until they hit the wall. When they hit the wall, stop. And when you want to, I think it's a great example. When you're done with that, I want you to try making a troll. Let's say they're between two walls and they're pacing back and forth like they're on patrol, pacing back and forth between two walls over and over and over again. How would I write that code? It turns out that it's not necessarily for trolls. This is a very, very, very common algorithm. So you keep doing something until you hit the stopping condition, like wall in front of you or at wall, maybe a test for at wall. Okay, and we'd have these series of sequences. So we have a sequence, we have input, we have input and output. Maybe not a lot of that for the troll. What the action of the troll is, and if there's any kind of decision. Okay, so I want you to try to work on this. Make at least one, but hopefully two different examples. The troll's walking towards the wall and stopping when it gets to the wall, and one where the troll keeps on walking back and forth between two walls. You're assuming there are two walls at least. Okay, and from there, and you'll also see there's probably I'm hoping that you start realizing there might be cases where a little edge case along the way. What if the troll is what if the distance between the walls is 400? Well, it shouldn't make a difference. What if other certain conditions are there? What happens in those cases, right? What happens if the troll starts at the wall, for example? So when we'll get back, I'll take a pause in the video, pause the video now, try this out yourself, and then we'll look at possible examples or possible solutions. Okay, hopefully you're back now. So let's have, or do I have an example? No, I left off the troll walking solution. So I'm going to do this. This is going to be the start towards the wall. And I'm going to have if you're at the wall, this end. All right. Notice I could have started walking and then checked if I was at the wall. Except, what happens if I'm already at the wall? I don't want to walk through the wall initially. I need to check first and then walk. So if I'm at the wall, no, I have a no at this, then I'm going to walk, and then this thing is just going to go back here. Am I at the wall now? No, walk. Am I at the wall now? No, walk. Rinse and repeat until I reach the wall. If there is no wall, I just keep going. That's correct. That's the correct behavior. That there's no way that the troll's going to know that there's no wall there. Your algorithm should work for based on certain always works based on certain contingencies. The troll in this case, quote unquote troll, is not actually intelligent. It's just a sprite moving around on the screen. So you would expect it to do, if you don't have things set up correctly, you would expect stupid things to happen. All right, let's try the other one. So I have my start. All right, I'm going to check again. And I apologize for my handwriting in this case. I'm checking to see if I'm at the wall. Okay, if I'm at the wall, by the way, there is no end state here. That's sort of the point. So then I can loop around here, go back here. If I'm not at the wall, no, walk. I need my better pen. All right, I'm going to walk, and then I'm going to go back here. Notice they both lead to checking to see if you're at the wall. Here's an edge case. The two walls are right next to each other, and the troll's in between. So all the troll will do in this case is, it's at the wall, turn. At the wall, turn. At the wall, turn. At the wall, turn. It'll just, if I have a worst hand drawing ever, all this thing is going to do is just keep on spinning around. That's what you would expect for this behavior, right? What you expect in this behavior is if it's squished between two walls, essentially it's only the space for itself, it's just going to rotate in space. That's what I would expect at least. And if there's any space to move, what it's going to do is it's going to walk until it gets to the wall, turn around, and walk and keep on walking until it gets to the wall again, and then turn around. And that's what this thing will actually do if you flow through this thing, right? So here we have, right? It's going to be, there's no wall there, walk. There's no wall there, walk. There's no wall there, walk. Oh, now I'm at a wall, turn around, and then I walk back afterwards. That's what I would expect this algorithm to do. So let's try this with some numbers. So I would like to think about this before we get going on this. So I have a group of 5 numbers, 0 to 4, and my index always going to start at 0 just because that's what we do. I want you to find the smallest, searching for a set of numbers and the value, and print the next one found. We're looking for a particular number. Let's call that number to find. We're going to look for some variable called to find in this list of numbers. So if it's not in there, I return either 5, some values outside the range, or -1, or something like that. Some kind of dummy value that you know can't work. Otherwise, I might say where I found it, like at position 2. If I'm looking for 42, I should get here and return that 2. Okay, try that out. Take a 5 minutes to try and think through this. Try it out, seriously try it out. Make sure you know how to do it, and then we'll go over a solution. Okay, so this solution was done previously for, here would be that search algorithm with pseudocode, right? I have some kind of counter. If the counter is less than the list size, then I get the data, which is the item at that counter position. So item 0, item 1, item 2, item 3. If the data is what I'm looking for, I print off the counter. Uh, get out if I want to potentially, or I could just print out when I find what I'm looking for. So in this case, it's going to print out all the examples of where that number is. So let's actually remove this again. Let's, oh, that doesn't work. Does this work? Hopefully. Yeah, there we go. So I'm going to print, if I have the number 42, every time I find a 42, I'm going to print out where I found that 42. I could have a whole bunch of numbers like that, printing it out to the screen. Otherwise, I increment the counter. Rinse and repeat. Notice my while loop starts here, ends there. My if statement starts here, ends there. My else statement starts there, ends there. Right? I use indentation to say if something is in the while loop or in the if statement. All right. Here's what the pseudocode, the flowchart might look like. I have a starting point, fine. I have a counter. I'm going to make a variable called counter, fine. I'm going to check to see if the counter is less than the size of the list. If yes, then I'm going to make the data equal to if the list is less than the size of that, then I'm going to make the data equal to the counter the item at that counter position. I'm going to make sure that the data is. I'm going to check to see if the data is equal to find. If so, if no, then I just increment the counter and loop around. If yes, I print the counter. Oh, I could this. Let's do this. I do need to return here. I want to fix that in the actual notes that you'll see. Just because if I want to bail out early versus the other way, I want two different approaches. Okay, so if the counter size is not less than the list size, I escape as well. They should have a one-to-one mapping. It depends on how you define what the problem is. And so whether I bail out when I find the first instance of the number or I print out all the instances of that number, that's open to interpretation. And that's the kind of question you might want to ask if you get onto an exam. So two different ways of interpreting that same question would lead to two different results. Ideally, what we want to be able to do is trace through our code. And that's where the flowchart's useful, because I can walk step by step through my flowchart with my finger, figuring out where things go and how things work. If you get lost, use your finger, right? Just point it on the flowchart and walk through everything. Put some arbitrary values on, see how it works. So here we go. I'm going to search for, let's see here. I'm going to search for the values. The values 23 and 11 are in there. I'm searching for 11. So at position 0, I have the value 23. At position 1, I have the value 11. So here we go. I start. My counter is equal to 0. So I can put my finger on these boxes as they go. Where they're red now, that's where my finger is. I check to see if the counter is less than the list size. Hey, it is less than the list size. I make my data equal to the value 23. Data is now equal to 23. Great. Counter is equal to 0. I check to see if 23 is equal to 11. Well, I'm assuming you think it is not. All right, great. So I increment my counter. I move back up again. I go to this if statement up here, right here. I go to that if statement and check to see if the counter is still less than the list size. It is. I check my data. The data is now equal to 11. Is 11 equal to the search value? Yes, it is. I print the value. I end. Let's search for 3. It's not on my list. So I'll go down my list, checking as I go. It's not equal to 23. I loop around. I'm at position 1. The counter is equal to 1 now. I go down. I check to see if I get the data. It's equal to 11. Is 11 equal to 3? No, it's not. So I loop around again. The counter is now equal to 2, which is equal to the size of my list, size length 2, and I follow this path to get to the end. I didn't find what I was looking for. You can try different scenarios as well, which is the important part. All right, so I had a bunch of other things in here. All right, so try and do a flowchart to find the max in a set of numbers and print the value in the index for that value, for that number. And you can also try and find the minimum of a set of numbers and print the value in the index for that number. That would be some really good practice for how to use a flowchart. and something that you can build on for the assignments. Okay, so I want you to try that out, and we're going to stop the video now, but try looking at that and see how well you do. That'll be an indicator if you understand the topic. All right, thank you very much, everyone, and I'll see you in the next video.